Okay, here I want to look at finding reference angles on the unit circle for each quadrant, quadrant 1, 2, 3, and 4. So remember our quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're going to take examples at each quadrant and how we can find the reference angle. And I also want to say that at the top I said how to find the reference angle of any angle in the unit circle. I do want to talk a little bit about that. When I'm looking for reference angles, I do want to keep my angles within 0 and 360 degrees, or 0 and 2 pi. So if I were to have an angle that maybe was larger than 2 pi or 360, what I want to do is I want to find a coterminal angle, and that coterminal angle needs to be somewhere between 0 and 2 pi. So let's keep theta somewhere between, 0 and 360 degrees. Or if we're talking about radians, let's do between 0 and 2 pi. Of course, 0 and 360 or 0 and 2 pi, they both represent the same place on the unit circle because we've made a rotation. Okay, for our first quadrant, our degrees go from 0, which is right here at our positive x-axis. That's our standard position, and it goes between 0 and pi over 2. Remember, pi over 2 is radians, and it's also the same as a 90-degree angle, depending on which way your angle is written. And it's very simple. The reference angle in quadrant 1 is just simply whatever the angle is. So wherever it is on quadrant 1, that is your reference angle. Now let's look at quadrant 2. So for quadrant 2, this would be an angle that has a terminal side that is located in quadrant 2. So our reference angle is the space that lies between pi and the actual terminal side. Right there, we need to find what this angle represents. So like I said, the angle started at the beginning, which is the positive x-axis, and it ends in quadrant 2. Now let's look at quadrant 2. Quadrant 2 is between pi over 2, which remember is 90 degrees, and pi remember is also 180 degrees. Okay, so the angle has not gone quite the whole 180 degrees, or pi. So to find the reference angle here, we basically can go to pi, and we can subtract off my angle, and whatever's left over will be my reference angle. So I have it written up here. Depending on whether you're in radians or degrees, if you're in radians, you'll take pi and subtract off your theta, which is, of course, this, and whatever's left over, that leaves, this is the reference angle. And same thing for 180 degrees. You go over to 180 degrees and subtract off theta. So let's look at an example. Let's first do one in degrees. Let's look at let's do 135 degrees, 135. Okay, this is located in quadrant 2 because the angle is between 90 degrees and 180, so we have 135 right here. So to find the reference angle, we simply would take 180 and subtract off 135. Whatever's left over should be our reference angle. So when we do that, what do we get? We get 45 degrees. Our reference angle is 45-degree angle. Okay, now let's look at an example in radians. Let's say we have 3 pi over 4. Okay, so finding 3 pi over 4, we just need to figure out where it lies on the unit circle. So look, if we come over to pi, we could rewrite pi in terms of the denominator 4. So pi is the same thing as 4 pi over 4. And if we actually took pi over 2 up here at 90 degrees, and we wrote that in terms of the denominator 4, that's the same thing as 2 pi over 4. So you can see 3 pi over 4 lies right here in between 3 pi over 4. Now, of course, I talked about this in an earlier video, but a quick way when you're talking about radians to figure out where the angle lies is if the numerator is 1 less than the denominator, we know that it lies in quadrant 2. So we are looking for this. Now, for the reference angle, if we use our formula about subtracting pi, we would basically say pi minus 3 pi over 4. and if we get pi, remember, pi can be rewritten as 4 pi over 4 minus 3 pi over 4. And when you subtract, you get pi over 4. This is our reference angle. But as I said before, with radians, a quick way of knowing is whatever the denominator of the angle is, which is 4. By looking at this, we knew that my reference angle was pi over 4. Okay, let's look at quadrant 3. So quadrant 3 is between pi and 3 pi over 2, or if we're in degrees, between 180 and 270 degrees. So for this one, if we have an angle, let's say somewhere here, that the terminal angle lies in quadrant 3, that means it's gone all the way past 180 degrees, plus an additional little part of an angle. And so our reference angle would be this area right here. So in this case, to find the reference angle, we would take the angle itself, which since it's larger than 180 degrees, we would subtract off 180, or we'd subtract off pi, depending on which one we're looking at, degrees or radians. That should give us our reference angle. See, our reference would be right here. So let's look at an example in degrees. Let's see, let's look at 240. All right, so this is located in quadrant 3 because the angle is between 180 degrees and 270. So it would be located about right here. Let's see, 240. So to find our reference angle here, we take the larger angle, which is 240. We got to subtract off 180 degrees. When you do that, you get 60 degrees. That is our reference angle. So our reference in this case is 60 degrees. Let's look at an example in radians. Let's do 5 pi over 4. Okay, so finding this, if we look at pi, we can rewrite pi as 4 pi over 4. And 3 pi over 2, we can get a common denominator of 4. We can rewrite that as 6 pi over 4. So 5 pi over 4 lies right here in between. This is 5 pi over 4. This is let's see, a third quadrant angle. So if you start at standard position, it goes a little past pi plus an additional amount. We need to find the reference angle. And the reference angle would be right in this little area here, in between the terminal side and pi. Okay, so to find this, we want to take our larger angle, which is 5 pi over 4, subtract off pi, and that ought to give it. So if we subtract this, we need to get a common denominator. Rewriting pi as 4 pi over 4. When you subtract these, we get pi over 4. This is our reference angle. So our reference angle is pi over 4. Remember, like I've said before, a shortcut way is when you look at 5 pi over 4 from the beginning, and when it has a denominator of 4, we know that our reference angle is pi over 4. Okay, now let's look at quadrant 4. So quadrant 4 would be an angle that somewhere the terminal side lies inside quadrant 4, which means it goes all the way around, but doesn't go quite 360 degrees or 2 pi. It stops a little bit short. So our reference angle lies somewhere between the terminal side and the x-axis, and the one that it's closest to, which in this case is the positive x-axis, which is the same as 0 or 360 degrees. So when we look at this circle, we have 0 degrees. We know that 0 is the same as 360 degrees. It's also the same as 2 pi, depending on what you're talking about, degrees or radians. So to find the reference angle in this case, we're going to go, the angle didn't go quite a whole rotation, so what we can do is we can take 360 degrees, subtract off the angle, theta, and that should give you a reference angle. Or if you're talking about radians, a whole rotation would be 2 pi and subtract off theta. That should give us our reference angle. Now let's look at a few examples. Let's see. First, let's do, how about 315 degrees? Okay, so we know that 3 pi over 2 is the same as 270 degrees. So 315 lies right between 270 and 360, so it lies right here. Okay, so to find the reference angle in this case, we were going to take, 360 degrees, subtract off the angle, theta. Whatever you have left over should be our reference angle. That would be 45 degrees. So our reference angle right here is 45 degrees. So let's look at an example in radians. Let's try 7 pi over 4. If we look at 3 pi over 2, we can rewrite that as 6 pi over 4. And 2 pi, we can write 2 pi as 8 pi over 4. So 7 pi over 4 lies right here in between 7 pi over 4. So fourth quadrant angle. So the way we can find this is we can go, if we went the whole rotation, which would be 2 pi, and you subtract off the angle 7 pi over 4, whatever's left over should be your reference angle. And we get, 2 pi over 4, if we convert it to common denominator, is 8 pi over 4. So 8 pi over 4 minus 7 pi over 4 is 1 pi over 4. Our reference angle is pi over 4. And so right here, this is my reference angle. And we can say this is pi over 4. Once again, looking at the angle from the very beginning, we know because the denominator is 4, we know the reference angle is pi over 4. It saves us some time. We don't have to do all this calculating. So this is how we find reference angles for each quadrant of the unit circle.